This program should produce a times table, so let's create our skeleton class here. The problem doesn't specify how big the table should be, so why don't we prompt the user for that information. We'll use our args processor. And as usual, we have to import that. And now we can get our value n for the size of the table. Okay, and our table is going to be provisioned as a two-dimensional array. It's a table with integers. And it has as many rows as entries for which we want to compute products. If we have n values here, we want our table to include everything from 0 up to and including n. So it has n plus 1 entries. Let's say n plus 1 rows and columns. So to provision it properly here, we're going to use n plus 1 and n plus 1. And now we have to create the table. Initially, it has zeros in it. That's Java's default. So let's create our table by going over every row. In this case, r is less than or equal to n because we want to include the top value as well. And now for each column. What we want to do is store into our table at a given row and column the product of the indexes of the table. So we want to store there r times c. We can run this program, but it doesn't produce any output yet. It prompts us for how big the table should be. Let's suppose it should be 5, and it runs the code, but nothing is produced out of this. For our next step, instead of producing the output in Java's way, let's produce a table that we really want to see. And we'll do this row by row. So our outer loop is going to iterate over all the rows. And within each row, we're going to be printing out each entry for each column. These we're going to print with space to the right, but all on the same line. Because we want a row to be showing its entries all on the same line. So I'm going to print out using print, not print line, and I'll print out the value of this particular row and column, and I'll put a little bit of space to the right. And then at the end of each row, I'm going to print out an empty print line, which is going to skip to the next line of output. So let's see what this looks like. Okay, so this looks much better. Here we see the first row, the second row, and the third row, and the contents of the table are displayed properly. Our next step would be to introduce column labels and row labels. To produce these labels, we want to emit a label row before we emit the actual table that would say 0, 1, and 2 across the top. The place to do that is before we actually make our table. So let's produce labels for each column by having a for loop. That puts a label out. And just as we did down here, we don't want to skip to a new line each time, so we'll use the print version. And what we want to print here is actually the value of C. And I'll put the space to the right, just like we did before. And perhaps after that's done, I'd like to print out skip to the next row, and then I think I'll print just some dashes to separate the labels from the actual column. Okay, so doing our 2 by 2, there's our column labels, 0, 1, and 2, and then there's our dashed line, and then comes the table itself.
To label the rows, I want to put out an integer representing the row index on each of these lines before the line itself is produced.
So the place to do that is here, label this row. And what I would print out here is the index of the row. Again with the print because we don't want to skip to the next line. And so I'll do R, and then I think I'm going to put a little space and a vertical bar just to separate the row label from the actual row. Let's see what this does. Okay, so this almost works. Let's see, I want to add maybe another space here to make the formatting a little better. And also, my column indexes are now off. They need to move over by a couple of spaces. So I can add some spacing here before I produce the column index. And let's see if this is right. Oops, I wanted that spacing to be just at the beginning, not in between each one of these entries. So let's add that spacing before we actually produce the column indexes. Okay, that's looking a little better. I need to scoot this over one more space. Okay, so that's looking pretty good. Let's try some bigger tables. There's my 3 by 3 table. We see the times as being properly computed. It's a multiplication table just like we wanted. Let's try some bigger values. There's 4. So with 4, the product of 4 and 4 and even of 4 and 3 gives us a 2-digit number. And we see the alignment is no longer what we wanted it to be. So our next task would be to format these entries so they all take up the same amount of space.
The key to taking up the same amount of space is to format the entries so they always occupy 2 spaces.
So for example, if I have a 4, I really want to put a space in front of it. If I have a 12, I don't. And the place to do that is here where we print out the actual entries. So what I want to do is capture the entry that I want to print. So I don't have to type that over and over and over again. And what I want to say is, well, if my entry is less than 10, and it takes up 1 digit, and what I'd like to do is this same print, but I'm going to add a space before it. And otherwise, I want to print it the way I used to. So anything that takes up 1 digit now is prepended with a space. Let's see what this does for us. Try our 4 by 4. So now these entries that are less than 10, things like 9 and 6 and 4 and so on, take up 2 spaces, and all the other entries take up 2 spaces as well because they already had 2 digits. Now my formatting is off up here for the column labels, so let's fix that. We need to scoot over one more and also introduce one more space at least, see if that works, between each column. Okay, there we go. This gives us the 4 by 4 times table. And this will work for quite a while. Let's go up to 5 by 5. 6 by 6 is looking good. My dashes are starting to fail me here. Now the reason why they're failing me is I just put out a fixed number of dashes. What I really want to do is put out a number of dashes related to the number of columns I have. So let's fix that. It looks like we need, is it 3 dashes per column? We can see if this works, and if it doesn't, we can fix it. And then here we'll just use this to skip to the next line. That's looking pretty good. So now the number of dashes that's printing is related to the number of columns we have. Let's try a bigger number of columns. Okay, so this is working just fine. Now if we try to do a times table that goes beyond 2 digits, so this is going from 0 up to 9, that's about all we're going to be able to do that looks nice, because the minute we go to 10, we have 2 problems. One is that our row labels now need to also be adjusted so that they take up 2 spaces instead of just 1, and now we have an entry that takes up 3 spaces. A better solution to this problem that would take into account the spacing more properly would involve writing a method, and we haven't gotten to methods yet. But the method would allow us to format all the entries to be as large as the largest entry in the whole table. And that would be an interesting thing to do after we've studied methods.